So we are looking at special factor patterns today. I don't like to focus too much on patterns, mostly because if you know how to factor, it's not a real issue. However, there are two, hello,
paper?
for to do work on. Mm-hmm. Okay, so we're going to start right here with difference of squares. Difference of perfect squares. First of all, what are the perfect squares? One, not two. 1, 4, 9, 16, 25. 5 times 5 is 25. And then 36, 49. 7 times 7. 64. There we go. That's 8 times 8. 9 times 9? 81. 10 times 10? 121 is 11 times 11. 12 times 12 is 144. 169. 13 times 13, 169. Okay, that's probably good enough. Fill the space. That must mean they're done. Okay, so I don't like thinking about the rule for factoring for this one because it actually factors just like we're going to learn how to factor tomorrow. So I know, for instance, number 3 is called difference of squares because I see two terms, first term, second term, and it has a subtraction. That's what the difference is referring to. All right, difference means it must be subtraction. Does it work with addition? No, it's a difference of squares, not sum of squares, okay? And when I look at this, we have perfect squares. When I see 36w squared, that's really 6w times itself, 6w times 6w. I have a subtraction sign. 25 is 5 times 5. It is 5 being squared. It is a perfect square. So each thing is a perfect square, and we are subtracting. The rule for factoring, if you have something squared minus something else perfectly squared, it factors into two bubbles. I like to call those two little bubbles, double bubble, as x plus y, x minus y. It is the sum and difference pattern. Again, I don't usually teach it this way, but so all I have to do is say, hey, set up my double bubbles. And when I do this, I think to myself, hey, what times what gives me 36w squared? 6w times 6w. And what times what gives me negative 25? Negative 5 and positive 5. That's how I factor it. I think it's just easier that way. I don't even think about a pattern. When I look at number 4, again, I see a perfect square in fraction form, but still a perfect square. And I see another perfect square. It's pretty tricky, but I'm going to double bubble this. And I'm going to ask myself, hey, what times what gives me 1 over 144?
Very small.
Something very small. Well, what gives me 144? What times what? 12 and 12, right? So what's going to give me 1 over 144? 1 over 12. Yeah. Yeah. So 1/12 times 1/12 is going to get me my first term, 1 over 144. And then I have to say, hey, last times last has to give me the last thing here. What times what is going to give me r to the 6th, s to the 4th? r, is it r squared times, like r squared s squared? If I multiply those together, does that give me r to the 6th?
No, the R needs to have one that's a 3 and one that's a
3 and 3. They have the same base. What do you do to the exponents? You add them? Okay. So, negative r cubed s squared and positive r cubed s squared. All right, 5, 16x, everybody's sneezing. I'm about to sneeze too. First times first has to give me the first thing. What times what? It's going to give me 16x to the 4th. 4 times 4 gets me the 16. How do I get x to the 4th? X to the 2nd times x to the 2nd. Very good. All right. All right. Oh, wait a minute. How do I get a positive? Does that work? Is this the right pattern?
Why didn't you see 1 plus 1? You're multiplying 1 by itself.
So if I did plus 1, is that going to give me 16x to the 4th? It's going to get an 8x squared in the middle. Yeah, this is not difference of squares. Tricky. You don't. This one is prime, actually, so it doesn't actually factor. Crazy. It's not difference. Is this one difference of squares? Yeah. All right, how do we get 9?
3.
Okay, 3 times 3 gives us the 9. How do we get a to the 4th b squared? A to the 2nd, b to the 1st. Very good. All right. How do we get the negative 100c squared? Minus 10c and plus 10c. Very good. Those are actually pretty challenging. Okay. So sum and difference of cubes or squares is not too shabby. It's just a sum and difference pattern. Pay attention to those signs, though. All right, we have a sum and difference of cubes. This does not come up a whole lot, but it is a good one to know. Perfect cubes is like 1 times 1 times 1. 1 cubed is 1. 2 cubed is 8. 3 cubed, 27. 4 cubed, 64. 5 cubed, 125. 6 cubed, 216. Yeah. 7 cubed. This is my favorite. 343. Because 3 plus 4 is 7 cubed. All right, and then 8 cubed, 512. 9 cubed, 729, and 10 cubed, 1,000. That's good.
How do you just pull it off the nose?
All right. Okay. So sum and difference of cubes do have a special pattern, and I do go by the pattern for these. The rule for factoring here is if I have something to the 3rd power, this is sum of cubes, so this means that we're adding 2 perfect cubes together. And so if I have a cubed plus b cubed, it's going to factor into what I like to call a small bubble and a big bubble. Small bubble, big bubble. So the way that I think about these is I'm going to put up the signs first, and for some reason I learned this when my first year teaching back in 2003. My first year teaching, and had to learn this pattern for the first time ever. Like, I didn't have to learn this in high school. And I remembered that my signs go plus, minus, plus for sum of cubes. So I'm going to put a plus sign, a minus sign, and a plus sign. And then I'm going to fill in the spaces in between. And it's the same pattern for both. But somehow 20 years later, I still remembered that the signs go plus, minus, plus. It is the root, the base, just the A and just the B, fill in the small bubble, And what we do from there is we square the first thing. So I square the A. I multiply together in the middle. A times B. I multiply in the middle. And then I square the last thing. Square the first, multiply in the middle, square the last. Every time. So here I have sum of cubes, and I'm going to just small bubble, big bubble. Small bubble, big bubble. How do the signs go? Plus, minus, plus. Put in the signs, and then you get to forget about the signs. And so now I just want to say, hey, H, because H cubed gives me that cube there. And then what times what times what gives me 125? 5. 1, 2, 3, 4, 5. 5 cubed. You can think about it if you want. This is H being cubed plus 5 being cubed, if you want to take an extra step here. Once you figure out your small bubble, you're going to square the first thing. Not yet. What is H being squared? A squared, And we're going to multiply them together in the middle. 5H in the middle, 5H. And then you square the last thing. 5 squared is 25. And you're done. It will never go further. All right? So that's all it's going to do. Square the first, multiply in the middle, square the last. Let's try number 8 here. So 8f cubed is really what quantity cubed? What times what times what gives me 8f cubed? 2f. And what times what gives me 27? 3. Okay. So you can do that step if you want to help you figure out your small bubble. How do the signs go? Small bubble, big bubble? Plus, minus, plus. Very good. And what are my bases here? 2f, yeah. 2f, and then the 3. And for the big bubble, we square the first thing. Here's where mistakes happen. What is 2f being squared? 4f squared. Very good. 2f times 2f is 4f squared. We multiply in the middle. What is 2f times 3? Sasha. Say it again. How about 6? 2 times 3. We just multiply 2 times 3 to get 6f. Yes. Very good. All right. And then square the last thing, we get 9. And we're done. Square the first, multiply in the middle, square the last. All right, looking at 9, small bubble, big bubble. What do the signs do? Plus, minus, plus. And so what cubed gives me 27a cubed? 3a, very good. 3a times 3a times 3a gives me 27a cubed. And what cube gives me 512? 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there, yes. 8 cubed. All right. Squaring the first thing. What do we get? 9a squared. Good. Multiply in the middle. What do we get for our middle term? 24a. Very good. 24a. And then square the last thing. 64. Raise your hand if you think you've got this pattern. Good. Then let's just do 12 and 14 of the difference of cubes. So difference of cubes means we're subtracting perfect cubes. So we have something cubed minus something cubed. And again, it's the same idea. We have a small bubble and a big bubble. It's actually minus plus plus. Yeah, so you keep the sign, change the sign, always positive. Keep, change, always positive is how that works, really.
How do I know the difference?
So if it's different,
No, like, how do I know the difference between these two?
so when you look at the problems that we have here,
Yeah.
these are cube plus cube. That'd be
Oh, I
sum
see.
of cubes,
Okay.
yeah. And now we're looking at difference of cubes, cube minus cube. Let's look at number 12. It's going to be small bubble, big bubble. And what do the signs do? Minus, plus, plus. Good. All right. What gets me 125? What times what? I'm starting at 12, yep. Yep. 5, good. And how do we get 8v cubed? 2v, very good. 2v times 2v times 2v would get me the 8v cubed. Same pattern. Square the first 25. Multiply in the middle 10v. And you do not have to worry about the signs here. The signs are already taken care of. And then square the last thing 4v squared. Very good. So the pattern is the same. Square the first, multiply in the middle, square the last. Let's do 14. We'll call it. Difference of perfect cubes. Small bubble, big bubble. What do the signs do? Minus, plus, plus. Good. All right. And then what are my roots here? What times what times what gives me p cubed? P, And how do we get 216q cubed? 6q. 6q times 6q times 6q gets me that 216q cubed. All right, square the first thing. What do we get? P squared. Multiply in the middle. 6pq. And then square the last thing. Q squared. Good. 36q squared. Yep. All right, questions on those? Okay. We have 2 more things to do. What time do we get out of here? 51. Okay, I have 5 minutes. That's my goal. 5 minutes. Okay. Let's go back up to GCF. GCF stands for greatest common factor. Greatest common factor. We need to look at these numbers and say, hey, what can I undistribute? Undistribute is what we're doing. Undistribute. What number can I divide both of these by? 6. All right, I can divide both of these by 6. And what about letters? What letters can I? Y to the third. Very good. Y to the third can come out of both of these. This is the greatest common factor, the thing that we can take out of both terms or all terms. It does not disappear. It is relocating to the head of the class. We are undistributing it. We are unmultiplying it back out in front, okay? So if I get rid of 6y cubed, what's left in the first term? 4y. Do you see that? Yeah, 24 divided by 6 is 4. Y to the 4th over y cubed is y. This is why we had to do exponent rules. Okay? What about our second term? What's left behind? 9. A negative and a 9. And what happened to y cubed over y cubed? It cancels out. Okay, we get y to the 0, which is 1. Okay? Bless you. How do you know if you did this right?
You should be able to multiply back.
Multiply back in. Absolutely. Distribute that back in. Okay, let's look at number 2. What number can we divide out of both terms? Yes, 17 is right. Good. 17 times 3 is 51. All right, what about the A's? How many A's can we remove from both of these? A cubed, very good. A cubed can come out of both of these. How many B's can come out of both terms? 4, good. B to the 4th can come out of both terms. 17, A cubed, B to the 4th, comes out in front, relocates to the head of the class. What is left behind? 3. A to the 5th power. How did we get the 5? 8 minus 3 is 5. Good. Top minus bottom. And then B to what power? 0. Yeah, B to the 0. Good. We have a plus sign. 17 divided by 17 is 1. A cubed over A cubed cancels out, and yes, we are just left with a just B. B to the 1st power. Are you good with GCF? One more. All right, turn the page. We're going to 4 terms today. 4 terms is GCF and GCF. When we have a 4-term expression, sometimes we can do factor by grouping, okay? That is what we do. We call it factor by grouping. Factor by grouping. But really, it's just the greatest common factor over and over again, okay? So what I like to say is, like Moses, we're going to stick our staff in the Red Sea and part the sea, okay? So I like to separate. We have 2 terms to the left and 2 terms to the right. And I'm going to look and say, hey, what can I take out of these first 2 terms? What is the greatest common factor? Can I take a 2 out of a 3? No. Just h squared can come out of both of those. All right, if I take out the h squared from each of those 2 terms, what's left behind?
2h plus
2h minus
3.
3. Very good. Yep. How do you know if you did that right?
Plug it in.
Multiply it back in. Yep. So h squared times 2h gives me 2h cubed. H squared times negative 3 gives me negative 3h squared. Okay? So check to make sure you're doing it right. Now, on the back 2 terms, looking at these back 2 terms, what can I take out of those 2 terms? A 3, okay? In this case, I want it to be a positive 3, so I'm taking a positive 3 out of both of those terms. If I pull a 3 off of each term, what's left behind? 2h minus 3. Very good. How do you know if you did it right? Multiply it back in. 3 times 2h is 6h. Good. 3 times negative 3 is negative 9. Are we done?
Yes.
No. We're going to do the greatest common factor one more time, because if you look, right now, I'm looking at 2 terms separated by addition. What do they have in common? They both have a 2h minus 3. So we're pulling a whole bubble out in front. And what is remaining when I take those 2h plus 3s and pull them in? The h squared plus 3. You see how that works?
Wow.
Whoa.
Oh, buddy.
No, there's not. So what's happening here, that's a good question. I'm going to go right down here. If I were to, I could do this a lot of different ways, but you can always double check by multiplying. What happens here is, one way that I can think about this is saying, hey, I'm going to take this whole bubble and I'm going to distribute it to each term in this other bubble. And if I think about it that way, taking a whole thing and distributing the whole thing, I would have an h squared times the 2h minus 3. And then I'd have the positive 3 times the 2h minus 3. So when we distribute, it's sharing, right? And so we're recollecting it back as one unit, okay? Does that make sense? And you can always, you could FOIL these together to check, and you'll get right back to this, okay? Let's try 22. Like Moses, what are we going to do? Part the C. All right. And looking at our first two terms here, what do they have in common? Z squared. You take out Z squared, what's remaining? Z plus 7. Beautiful. Now we look at the last two terms, trickier here. What do they have in common, almost? Negative 5. They both have a negative. So what do they have in common? Negative 5. Ooh, I take out a negative 5 from both terms. What's left behind? Z plus 7. And again, whoa. So you got to check it by distributing. Negative 5 times Z is negative 5Z. And negative 5 times 7 is negative 35. Okay? Yeah. So when we look at that, are we done or we got one more step? We got one more step. Because once again, now I have two terms here. Do they have something in common? They do. They both have Z plus 7. And if I, again, undistribute that Z plus 7, what's left? Good. Z squared minus 5. Okay. Raise your hand if you think you get this. Raise your hand if you've done this before. Okay. All right. Let's just do this last one right here. Shouldn't do one with a 1. I would have done one with a 1. All right, last one. First two terms, Ellis, what are the things we have in common here?
4.
And?
C squared.
Good. And what's left behind? Good. C plus 5. Very good. Last two terms, what do they have in common? 9. A positive. You always need a sign. Please. There must be a sign, positive or negative. We're going to take out a positive 3 from both of those. I'm sorry. No, it's not 3. What is it? 9. The greatest common factor is 9. That'll be a little better for us. If we take out the 9, what's left? C plus 5. Do we have another match? We do. So we're going to undistribute the C plus 5, and what's left behind? 4C squared plus 9. All right. That is pretty good. Ooh, that was a lot of notes. That was kind of a long time.